Students, this is the help video for the finals review packet, multiple choice portion, units 1 and 2. We're only going to get a head start on the starred problems. I'm not going to do the entire problem with you. It says all the starred problems have a partial explanation, keyword there, partial. Of course, this first one, basic algebra, I'm not going to show you how to do it other than when you distribute, please make sure you circle and physically distribute, circle, physically distribute. Be careful with that when you solve for the variables. Radicals we are going to do because it's been a long time since you've seen them. When you simplify, what you want to start by doing is reducing every radical first. Take a look here at this first one, and we have a pair of 2's, which means they're going to be simplified out of the radical, and you multiply on the outside, so that's going to end up being 6 root 3. Another pair of 2's come out, that's going to be a 2 on the outside. 2 times 3, that's another, and that's a minus sign, so that's going to be minus 6 root 5. No dates here, so there's no one coming out. Minus 3 root 3, minus 3 root 3. Now, you look at the radicals, and you're going to collect like terms. So rather than show you what to do, let me help you visualize it. This is as if this is 6x minus 6y minus 3x minus 3x. Think about how you would collect like terms for this one and then follow the same rules for the radicals. The key idea here is things before algebra. Things. Think in terms of things, how things add up to other things. So taking a look here, I'm going to do the one on the right or get you started. We can see that we have, I'm going to color code it for you, this red segment and this blue segment, and the green segment, and the yellow segment, and you can see that the red minus the blue will get you this QR. Red minus blue gets you the QR. Notice the yellow minus the green will also get you the QR. So let's do here things before algebra. Red. So our red segment QS minus the blue segment RS will get you that leftover segment QR. The yellow big segment QT minus the green, which is RT, also equals the leftover segment QR. If things are equal to the same thing, they are equal to each other. So we know QS minus RS, red minus blue, is going to equal QT minus RT, yellow minus green. Now you can put your algebra in here. QS is going to be 8. RS, 3x minus 2 watch this very carefully. It's minus the entirety of 3x minus 2. So you must put parentheses around that. Equals qt, 3x minus 4 minus rt, which is simply 4x. So here's the trick to the entire problem. This negative sign has to be distributed in order to solve for x properly. Solve for x, and then plug it back in, and you're not just finding x. I want you to find q to t, which is going to be 3 times x plus 4. Things before algebra. Okay, it says find the measure of the angle indicated in bold. However, I would get in the habit of finding everything impossible, so that's the bold angle. You want to sweep here, and now you need to look in your reference booklet, and since we're dealing with parallel lines, you are looking for one of these 4 angles. They are the congruent angles. There's 3 of them. Alt-in, Alt-X, corresponding, one's in, one's out, same side. And then you have your supplementary set of angles, which is consecutive interior, also known as same side interior. These are not congruent, they add up to 180. So we look here, and what we have is corresponding angles, and they are congruent. So your thing equation, at least for this one, is going to be angle equals angle, and you circle plug chug. And you solve for x and plug it back in. Said find the other endpoint of the line segment given with a given endpoint and a midpoint. So what we have here is we have an endpoint, -6, 0. We want the other endpoint, xy, and we're given a midpoint, -4, -8. By definition, midpoint means the distances between these two are equal. So what you're thinking is this. From -6 to -4, whatever that distance is the same distance from -4 to x. So we'll just do the x portion. From -6 to -4 is 2 units. Distance is always positive. And we're going up the number line from -6 to -4. So what's 2 units away from -4? It's going to be -2. Y is found in the same way. Another way you can do this is you can actually visualize it, which is also a good idea, xy. Our endpoint is -6, 0, which is approximately right here. Our midpoint is -4, -8, which would be about right here. Then you're being asked to find where the other endpoint is. So it's something like this. And this way you can simply use slope. Count the slope here, and then the slope has to be the same to get to that other endpoint. Slope, you should know how to do that. Y minus y over x minus x. Distance, it's the giant square root, x minus x, parentheses squared, y minus y, parentheses squared. Sketch a graph of each line. To sketch a graph, you need to get y by itself. So the goal is to get y by itself so that you can get it into y equals mx plus b. So the goal is to get y by itself. So for this first one, what we're going to do is we're going to bring that y over to the other side to get it by itself. So I end up with 4y equals negative 5x plus 12. I'm going to divide by 4, and you must do every single term, so that finally I get y equals negative 5/4 x plus 3. When you graph, starting at 3, we know it goes down from left to right. So there's 5 and 3. Says, write the slope-intercept form of the equation of the line described. And notice we have two which are parallel, two which are perpendicular. And remember, for parallel, the slopes have to be equal. For perpendicular, the slopes multiply to -1. And it says we want the slope-intercept form, which means we want this form, y equals mx plus b. I'm only going to do one of these. I'm going to go ahead and do 25. Said we want the equation of a line which is perpendicular to this, what I'm going to call this the given line. And then you're going to have a secondary line. It's going to go through this point, but be perpendicular. So I'm going to do a little quick sketch of that first one. So y equals 1/3 x plus 3. So we're starting at +3. And our slope is 1/3. So that means up 1 over 3 to the right. 1/3. So our given line is approximately right here. Now our derived line, we wanted to go through the point +1, -2. So +1, -2 is about right here. And we want it to be perpendicular to that line. Now, you cannot solve this just by graphing because the final answer might be involve a fraction, and it's hard to see that when you're just graphing. So we have to solve it algebraically. So we're going to start by doing y equals mx plus b. Start with our slope. Our slope is the perpendicular slope, which means perpendicular, it must be the opposite reciprocal. So our slope is negative 3/1. 1 is our x. 2, negative 2 is the y. We're going to solve for the b. b equals positive 1. So our equation is going to be y equals negative 3/1x plus 1. That's our perpendicular equation. Now let's graph that and see if that actually works. So at positive 1, down 3, 1, 2, 3, and over 1, that does put us there. You graph. Lo and behold, now we have that secondary line. It goes through that given point, 1, negative 2, and is perpendicular. We want the slope-intercept equation of a line through the given point. Slope-intercept is y equals mx plus b. Y equals mx plus b. So the first thing we're going to do is we're going to find the slope. Slope is y minus y over x minus x. So that's going to be y minus y over x minus x. Double negative makes a positive. So I have negative 1/2. Now what we need is our b. So y equals negative 1/2 x plus b. I need to solve for the b, so I'm going to replace this x and this y with one of the 2 points, and I'm going to use the one with the 0 because it cancels it out. It makes it a little bit easier. So our x is going to be 0, and our y is going to be negative 4. So negative 1/2 times 0 cancels. So it's easy to tell what your y-intercept is, which is negative 4. So the final equation for number 27 is going to be y equals negative 1/2 x minus 4.